All right, here we go. Here's the next one for the evening. This is from the 2017 BC International Exam. This is question number 4, which means it's a calculator inactive question. Put those calculators away. Okay, we're told that the function f satisfies the condition that f of 0 is equal to 20. The first derivative of f satisfies the inequality 0 is less than or equal to f prime of x is less than or equal to 7 for all x in the closed interval 0 to 6. Selected values of f prime are shown in the table above. The function f has a continuous second derivative for all real numbers. Okay, lots of information going on here. In part A, use a midpoint Riemann sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of f of 6. Okay, I need to get my head wrapped around this one. We know that f of 0 is equal to 20. Okay? We've got information about the derivative. We have this restriction over here, which is maybe a little bit new, where we're told that f prime is always going to be between 0 and 7. Maybe that's going to be important on the closed interval 0 to 6. And the function has a continuous second derivative. So that means one way to say that is f is twice differentiable. So that's good. All right, we want to find f of 6. Well, how do I get an approximation for this function if all I have is one point and some information about the derivative? What comes to mind for me right away is the fundamental theorem of calculus that says that the value of my function at 6 has to be equal to the value of my function at 0 plus the total change in my function, plus the total change of the derivative of the function from 0 to 6. Okay, now they then go on to say use a midpoint Riemann sum with 3 subintervals of equal width. I'm trying to go from 0 to 6. I need 3 subintervals, and they have to be of equal width because they told me that. So each interval has a width of 2. My cut points are 0, 2, 4, and 6. But I want to be careful. I'm supposed to use the midpoint method. So on this subinterval, I don't use the value at 0. I don't use the value at 2. I use the value of the derivative at 1. On this subinterval, it's going to be the value of the derivative at 3 and the value of the derivative at 5. To approximate the area under this curve using that method, well, what do we know? F of 0 is 20. And now to approximate that, I'm going to say it's the width of this interval, which is 2, times the value of the derivative at 1, because that's the height of the rectangle. So f prime of 1 is 3.5. That's the first rectangle. Your second rectangle has a width of 2. Now the value of the derivative at 3 is 0.8. Multiplying those two together gives me that next area. The last interval has a length of 2 times the height of the function is 5.8. So 2 times 5.8. I've got my initial value. This part over here approximates the integral of the derivative. This is a calculator inactive question. Now, if you're in Calculus BC, I would assume that you can multiply these numbers together and add them together correctly and come up with the right answer. But the point is, you don't need to. There's no need to go and do that work. These are all numerical values, so you can stop. In terms of how the College Board awarded the points, they said 1 point for recognizing to use the fundamental theorem of calculus, 1 point for this general form, and then 1 point for the numerical answer. Because of the way I chose to write this out, the form and the form really is the answer. Here's a quick example of what somebody might do that would require two steps. They might say, okay, f of 6 is approximately the initial condition plus 2 times the value of the derivative at 1, plus 2 times the value of the derivative at 3, plus 2 times the value of the derivative at 5. This person would get 1 point for having the form of the midpoint sum, but then would have to go an additional step and say, what is f prime of 1, what is f prime of 3, what is f prime of 5 to get that second point. Because of the way I did it here, you get both points at the same time. No matter what, it's a 3-point question, and now we get to move on. Okay, part B says determine whether the actual value of f of 6 could be 70 and explain your reasoning. Well, what do we know? We know that f of 6 is equal to f of 0 plus the integral from 0 to 6 of f prime of x dx. We know that f of 0 is 20. We don't know exactly what the value of the integral of the derivative is, but remember earlier they told us that the derivative was always going to be between 0 and 7? If that means then the largest value that the derivative could take on is 7, imagine graphing the derivative. Here's the horizontal line, y equals 7. You're told that on the interval 0 to 6, the derivative is always trapped between y equals 0 and y equals 7. So maybe your derivative looks like that. Well, what do you know about the area? The area, if f prime is always bounded by 0 and 7, then the area bounded underneath f prime of x from 0 to 6 has to be no more than the area of this rectangle. The length is 6, the height is 7, so the area of the rectangle is 42. That must mean that the definite integral has to be no more than 42. So I'd say that this has to be less than or equal to 20 plus 42, which is 62. 62 is the maximum value that f of 6 could have. Therefore, f of 6 cannot be equal to 70. So, a little bit different of an argument. You've got to take into account the fact that you're bounded, you have an upper bound for the value of the derivative, and you can make that work. So, what did they say? This is worth 2 points. 1 point for coming up with this value of 42 as your maximum bound, and then 1 point for coming up with your conclusion that says no, it's not possible, and having some evidence to support that, for a grand total of 2 points. Let's keep going. In part C, we're asked to evaluate the integral from 2 to 4 of f double prime of x. Well, what do we know here? You're being asked to evaluate the integral of the second derivative. Well, here's f prime, here's f double prime. I know that these are all related by derivatives, but that also means that they're related by antiderivatives. The integral of f double prime is f prime. So I've got f prime of x that I need to evaluate from 2 to 4. I'm going to do that by finding f prime of 4 minus f prime of 2. Where does f prime of 4 come from? You're going to go to your table. F prime of 4 is 1.7. F prime of 2 is 2. That's equal to negative 0.3. Of course, you could have stopped right here. You get 1 point for using the fundamental theorem of calculus. Basically recognizing that the integral of the second derivative is the first derivative. And then 1 point for your answer. You can't stop at f prime of 4 minus f prime of 2 because those are not numerical values, but a safe stop is this 1.7 minus 2, or of course you could have gone all the way to negative 0.3, and that would get you your 2 points. Okay, not bad. We're trucking along nicely. Part D. In Part D, we're asked to find the limit as x approaches 0 of f of x minus 20 times e to the x divided by 0.5 f of x minus 10. Okay, well, it's been a little while since we've worked with limits, but I know one of the things that we used to do, one of the first things we would try when evaluating a limit is plugging in. Well, let's see what happens. F of 0 minus 20 e to the 0 over 0.5 times f of 0 minus 10. Well, let's see, what do we know? F of 0 is 20. 20 times e to the 0 is 20. F of 0 is 20. We're getting 0 over 0, which you should recognize is the indeterminate form, which is a sign that what you need to do is think about L'Hopital. Now, I've been told on very good authority that the College Board has increased the rigor when it comes to L'Hopital's rule questions. They are very, very specific on this. You need to evaluate the limit of the numerator and the limit of the denominator separately. So you find the limit as x approaches 0 of f of x minus 20 e to the x. Now we've already done all that. We said that's going to be f of 0 minus 20 e to the 0, which is 0. You then have to evaluate the denominator, which is 0.5 times f of 0 minus 10, which is equal to 0. Because both the numerator and the denominator are approaching 0, now we can say by L'Hopital, our limit of f of x, limit as x approaches 0 of f of x minus 20 e to the x over 0.5 f of x minus 10 is equal to the limit as x approaches 0. You take the derivative of the numerator, f prime of x minus 20 e to the x, divided by the derivative of the denominator, 0.5 times f prime of x. Now you evaluate this limit, which is f prime of 0 minus 20 e to the 0, 0.5 times f prime of 0. Well, what's f prime of 0? F prime of 0, we go to the table and we know that that's 4 minus 20 e to the 0 over 0.5 times 4. Simplify if you want to. You're going to get 4 minus 20 over 2. That's negative 16 over 2, which is negative 8. They're going to be very, very, very particular about your showing these limits separately and then saying that because both are approaching 0, you get to use L'Hopital. That's the first point. And then all of this work leading to the answer of negative 8 is going to be where the second point comes in for a total of 2 points. Nice job.